Hey, what's up everybody? Toby here, and welcome back to another Onshape step-by-step tutorial. Today we're going to do a very special edition. We're going to do this case here for guitar picks. So you can see I've got some guitar picks in there. This case is kind of cool. It's got a little ramp here so that you can really easily just slide the picks right up that ramp, and then they slide out. But the case also, when you close the case here, kind of snaps into place, and that way it doesn't flop out. The picks don't end up falling out if it's in your pocket or anything like that. It really holds on there nicely. So one thing to say about this design, if you do decide to 3D print this, in the previous video we showed how to create the lid here, and now in this video we're going to show how to create the case. If you do decide to 3D print these parts, just keep in mind that when you go to assemble them, you have to put the lid into the track a little bit, and then you have to apply pressure from the bottom here, and that'll let you get that first bump up and over. So that bump stops the lid from like sliding off when you open it. And then the second bump here, there's these two bumps here on the underside of the lid. That's the second one. That second bump there is the one that you can kind of push down to kind of snap everything in place and hold the lid in place there. So we modeled up this lid in the last video. We're gonna set that aside for now, and we are gonna model up this case and see how it's done using Onshape. Now, this case comes from the toby library of 2D to 3D CAD exercises here at Practice Models. And this case is in honor of one of our contestants in the recent CAD vs. CAD high school tournament. So the students from LeGrand High School all got together and competed. And each month I'm gonna go through and recognize a different competitor in this tournament, starting with this first month and recognizing Smiley. So Smiley plays electric guitar. I thought it'd be cool to put together a case that we can hold our electric guitar picks in. So I'm gonna click Get Started here on Practice Models, and we're gonna go all the way down to the bottom. This is a Practice Models premium model. So this is 25-01-21 and 25-01-20. That was the lid. This is the case. So I'm gonna click here to practice, and we can see, wow, 2 people have done this already. So we're gonna become hopefully the 3rd person to successfully complete this challenge. And click here to begin. And go! What is the mass of this part in xx.xx grams? xx.xx grams. So even though the clock is running, I think it's always good to kind of come up with a game plan before we get started. And I think in the case of this model, I'm gonna start by figuring out where the origin should be. And I think the origin is gonna be located right here. The model has symmetry. I think it makes a lot of sense to just have the origin located right there. And so that means that I think my first sketch is gonna be, I think I'll use the same strategy as last time, where I'll just model up half of this. So my first sketch is gonna look something like this. So I'll create that line that comes over, I'll create that 10mm radius, create this shape here. That'll set me up nicely for a mirror a little bit later on. Now, once I've got that sketch 75 by 41/2, then what I can do is I can extrude that sketch down to this height here of 15. And then, because we've got all these wall thickness 3, wall thickness 3, wall thickness 3, well, I should be able just to go in and do a shell, right? We can do a shell command and apply that wall thickness 3 all the way across the board. So you can see that you're gonna notice some dimensions like this radius 5 and this radius 2. Well, again, that's kind of reinforcing that I could add that radius 5 first, and then I could shell it and get that radius 2 on the inside. Then I think the next feature that I would create would be this groove here. So you see we've got this angled groove. You can see here that the depth of that angled groove is 60mm. That matches right up with the rail on the previous part that we created. And then we can see the geometry here for that angled groove. So it looks like it's 35 wide. That's gonna be, I think that'll be the same wall thickness, or representing that 3mm wall thickness. So yeah, I mean, in this view here, you can see this wall is the same wall as this wall here. It's all the same face. So that's going to be that wall there. And then that angled groove shape is going to look something like this. It's going to come over, up, over, down, because we're only doing half the model. And then we've also got this ramp here, this ramp that we talked about to get the picks out of that case. So I think to create this ramp, it even says here, hint, extrude this shape from the midplane up to the walls. So a nice little hint there. So I'll create a shape that'll look something like this, over, down, back over this way, up. And then we should be able to extrude that right up to the walls, right up to the sidewalls, and create that ramp. And then the final features that are on this model are just these final fillets here. So we've got this fillet here, these blue fillets running around the top, and this radius 1. Since radius 2 and radius 1 are both smaller than the default wall thickness of 3, I think it's okay to save those fillets for the end. You probably don't want to have them in there before you do the shell, although I don't think it's really going to hurt you. But there are some CAD packages where that would be problematic. So I'm going to save those fillets for the end of the model, and then I should have pretty much everything on one half of the model, and so the final feature will just be a mirror all to mirror everything over to the other side. So I know we took a couple of minutes to come up with that game plan, but I think it's always good to come up with a game plan before you proceed with a 2D to 3D conversion. And if you agree, be sure to hit the like button on this video. And so now what I'm going to do is take this and move it over here to my second screen. Let's bring up our keyboard cam so we can see all the cool shortcuts that we're using here. And let's choose to create a new document. This is going to be in the public space, so if you get lost or if you get stuck, you could always search for this document in the Onshape public space. I'm going to call it -21 Smileys case and create public document. And then the first thing I'm going to do is go up here to this hamburger menu and choose to set my workspace units. Workspace units are going to be set here to millimeters and grams. Hit the green check mark, and then I'm going to go top plane, begin a sketch, orient my view, N key, normal 2. So I'm looking normal 2 down on the top plane. That's where I'm sketching. And S key, line, single click, move my mouse over this way, single click, let go of my mouse, 75, enter, move my mouse down this way, single click. This is going to be 41/2. I guess I could have just done this with a rectangle. Move my mouse back this way, move my mouse up this way. Nice fully defined rectangle there. And then I could either add in this fillet here at the sketch level, or I could add it at the feature level later. Honestly, I usually prefer to add fillets at the feature level, so I'm just going to do it as an extra feature here. So S key, extrude. And this is going to get extruded down to a height. Actually, you know what? Before I move on here, let me go back into this sketch. Sorry, let me go back into this sketch. I'll just show you one more trick. I showed this in the last video, but I think this is a good trick. If you're going to model half the model, but the customer has given you the full dimensions of the model, maybe what you want to do is create a construction line. So I press the letter Q there to change that line into a construction line, and then get rid of that 20.5 dimension and add in a dimension that goes from this line to the construction line, 20.5, and then go across the construction line. And that gives you a double dimension. And that might be a little bit easier to look at. It might be a little bit easier to work with the customer or confirm the customer's design intent. So this is what your first sketch should look like. Take a look at my sketch. This should look very similar to your sketch. And now we're ready to S key extrude. Remember, I customized my S key menu, so S key extrude. And then after you jump into the extrude command, you can just press tab, tab, tab. And this is going to go to a height of 15, enter. And it doesn't really matter if you want to have that extruding up or extruding down. I'm going to have mine extrude down, but it doesn't really matter. It's just like a preference, personal preference thing. So if that works for you, you know, you're going in the correct direction, you're going down, then you can hit the green check mark. And there you go. We'll call that feature Shift N, call that main base. And then what we could do is we could do S key fillet, and we can say we want this fillet to have a radius of 10 millimeters, and we click on this edge here and enter. Yes, that looks good. And then we could call that one Shift N fillet front corner. And then we could do S key fillet, and we can make that one a radius of 5. And then we could click down here on this edge. It looks like that fillet runs all the way around. So because of tangent propagation, that's running all the way around. So we can hit the green check mark, and then we could call that one Shift N fillet lower edge, something like that. Always good to rename your features. That'll really help you kind of keep things straight. And so now this thing's looking pretty good. I think we're ready to shell this thing. So we're going to say shell, and the shell thickness here is going to be 3 millimeters. So shell, and the shell thickness is going to be 3 millimeters. And then we're going to remove this face on the top, obviously, but we're also going to remove this face here because remember, we're going to model half of this and then we're going to mirror it across. So remember to get that middle face as well. You should be removing both of those faces when you do that shell. And so once you do that, you can hit the green check mark and boom, there you go. There is your kind of main shape there. I don't think we need to rename the shell. It's pretty obvious what a shell is. So I usually I don't rename that one. So now I think we're ready to add in that angled groove. So you pick this face, S key, begin a sketch, N key, get normal 2, S key, begin a line, single click here at the origin, come over to about here, come straight down, come over at an angle, come back over this way, come up to here. And then if you're going to be doing a double dimension, you could maybe create another line here and press Q to create that other line to be construction. I don't think we actually need a doubled line here for this one, because the dimensions that we add here are a dimension for the total height of the groove, which is 3 millimeters, 3, and a dimension for the angle of the groove here, which is 45 degrees. I guess we do have that total 35 from here to here, which we could make that collinear to the existing edge, but we could also just type in a dimension there. Both of those are going to work. And then we could create a final dimension here from this side of the part, this side edge here, to this point of the groove, and that is going to be 1 millimeter. So that's what the sketch for the angled groove should look like. Once you have all that geometry in place and you have it fully defined, you can press your S key, you can go into extrude, and this is going to be a remove. So up here in this box, remove, because we're doing a cut, and that's going to go to a depth of 60 angled groove. So there you go. That's going to be where that lid slides into place there. And so now we just have to create that. Let's rename that feature. So you click here, Shift N. We'll call this cut angled groove. And then we can click here on this face, which is kind of like the mid plane of the model. S key, begin a sketch, N key to get normal to. And then we can press the S key and we can pick a line. Don't pick up on the midpoint here. Go a little bit below the midpoint. Come over, come down to an angle. You can hit escape, S key, smart dimension, and we can dimension here, or just dimension, excuse me. We can dimension here at 45 degrees for that ramp. And we can say that that's going to be 8 millimeters from the very bottom of the part, 8 millimeters from the very bottom, and it's going to be 22 millimeters from this end of the part, 22. So I think that's all you need for that sketch. I think we can pick up on these other edges because they're part of this face that we're sketching on. So get that sketch to look like this, get it to be fully constrained, fully defined, and then we can choose S key extrude. And then you can press the space bar here where it says missing faces for sketch 3. Just press the space bar. That's how you clear those selections. And then you can just pick here in this region. So that's the region that we're extruding, and we are going to extrude that up to part. And then you just pick here on the part. There you go. Look at that. There's your ramp. And right up to that part. That looks pretty good. So we hit the green check mark, and then you can Shift N. We'll call this ramp area. That's so that when you go to slide the picks out of that case, they just they slide right out. You can do one-handed operation. Use your thumb to open the case and then use a finger to pull those picks out. And they just slide right up that ramp, and it works beautiful. And so now we need to add just a couple of final fillets here, going right along with the game plan. So S key, and we will go fillet. And usually I add my fillets in order from largest to smallest. So I'll make this one 2 millimeters here. And that 2 millimeter fillet is going to go around this edge here, running all the way around the top. So if you keep this case in your pocket, it doesn't poke you in the leg. And so we can hit the green check mark there. And then a final fillet here on this end. So fillet, this one is 1 millimeter. And because we added that 2 millimeter first, we also give ourselves a nice edge that 1 millimeter can wrap up and around. And so we hit the green check mark, and then we can choose the mirror command, mirror. And we're going to do a mirror here. This is going to be a mirror using this part. And then for our mirror plane, so first you pick the part anywhere, then you come back up here, click mirror plane, and then you pick this face here, and there is your mirror plane, mirroring that part over, and we hit the green check mark, and look at that. So again, to rename these, you could call this something like, you got to be a little careful. You don't necessarily want to name your fillet like fillet 2 millimeter, because what if that radius changes in the feature, but you forget to change it in the tree? It's going to be confusing later on. So this could be like around top. And then maybe this one we could call small fillet end, something like that. Name it based on like its general size or its location or its function. That's a lot better than naming it based on the actual radius. And then this mirror here, a lot of times I'll just call this mirror all, just so that I know that that's like my final mirror. And so then if you want to, you can change the color of the part. That's always helpful with the customer. Right mouse button, edit appearance, and you can make this like a gray, like what the customer's calling out. You can press P and Shift P to hide your planes and hide all your reference geometry. And then finally, you can right mouse button on the name of this part and go to assign material. And this material is going to come from the TTT custom materials library, and it's going to be 1060 aluminum. And the reason we did 1060 aluminum is that it just worked out better for the weight calculation. When I did it out of ABS, it was not really coming up with a good number. So I just changed it to aluminum. But obviously when you 3D print this, you'll print it out of, plastic, not aluminum. So we hit the green check mark here. I mean, I guess if you know somebody who's into machining, they could machine this part for you out of aluminum, and it would be an epic pick holder. So hit the green check mark, and then down here in the corner, you can choose the little scales there. Click on the name of the part, and we're coming up with a mass here of 48.4, but it's actually asking for this in XX.XX. So if you hold your mouse over the number, then you get a more detailed number over here. So 48.43. So 48.43, so we go over here to the answer, 48.43, and enter. And oh yeah, we did it. Congratulations. This answer is correct. Yes, we did it. And so that is the tutorial on how to model up that part. Now, of course, once you're done with that, you can click submit here. And now that we have a few people who have done this, 3 people have done this, we can see how well we did against the other people. So my time was 13:07. The average time was 8:58. Wow. Fastest time, 5 minutes and 44 seconds. And this model just went up earlier tonight. So that's pretty impressive for having just gotten done with it. So looks like it was a SolidWorks or an Onshape user, a SolidWorks user, and an Onshape user. I love it. I love it. So now what we can do is we can go back into Onshape. And then in Onshape, we can come down here to the name of the part, right mouse button, and choose export. And then once you choose export, you can choose here to export this as Smiley's lid. I'll just call this V1, it's the first version. Export it as either STL or 3MF for 3D printing. So I'll do STL. Make sure your units are set to millimeters so it comes into the build table correctly, and make sure your resolution is set to fine, and then you can choose export. And then what'll happen is this will get exported. I'll just choose to save this here. We'll call this Smiley's Base V1. So if you put it into your preprocessor and you position it something like this, that should work nicely. You don't need any supports for this. Like this overhang here with the fillets, most 3D printers can handle that. And the overhang here for the groove, most 3D printers can handle that as well without needing any support material. So you don't need to go in and add supports. You can just print it as is, and you should have enough of an overhang there that the 3D printer, the FDM, can handle that. So give that a try. Let me know how it goes. Post images of your 3D prints in the Discord. I always love seeing that stuff. And if you enjoyed this tutorial, be sure to hit the like button on this video. Be sure to let me know down below if you have any questions or if you learned anything cool from this tutorial. And thank you so much for being a Practice Models Premium subscriber. This is an exclusive challenge just for Practice Models Premium users. And I really appreciate your guys' support in this adventure. So thank you so much. And like I said, let me know down below if you have any questions. I'll see everybody in the next one.